Hello, biology world. Paulus coming to you from the Paulus pad. Purpose of this video is to allow those that missed class when we were doing notes on 2-2 to get caught up. Or maybe during class I went too fast. And you just simply need a couple blanks to fill in. Or maybe you're just bored out of your skulls and you want to watch Paulus talk about water. Okay. Speaking of water, I want you to know how much I am here for you. I am missing the Dolphins. There's the water reference game against the Jaguars, just so I can make this video. They're really important to me. The Dolphins. Well, Dolphins in general are important to me, but the team is really important to me. I'm recording it though, so I'll be good, and I don't like watching commercials anyway. I just want to see the action. So in any event, without further ado, let's get started. If you're typing them, you're going to need, let's see, we're going from 13 to 21, 13, 14, 15, 16, 17, 18, 19, 20, 21. You're going to need 9 rows, 2 columns, because we do class notes in Cornell note style. If you're writing, draw a line down the center of your page, and we are starting with number 13. We're not starting with number 1. No, that was 2-1. We're starting with number 13. Here we go. Characteristics of the water molecule. By the way, if me talking and elaborating, which means expanding upon the information that is what you're supposed to write or type. If that is making it hard for you to focus, you are welcome to turn the volume down. Maybe you don't want to hear me talk. I get it. You hear me talk a lot. But you will miss some of that elaboration. Okay. The way that you will know that I'm about to go to the next slide, if you do not hear me, is I will do this. I will point at you. And that means you have about 3 or 4 seconds to pause the video before I go on to the next slide. All right, here we go. Characteristics of the water molecule. It's neutral. Okay, thank goodness it's neutral. If it was acidic or if it was alkaline, basic, we would burn all the time because we are mostly made out of water. It's polar, and you'll learn in just a bit what polarity means. It doesn't mean it's cold, like a polar bear. Okay, number 14. Again, please number them. Questions on the left, answers on the right. Paulus, that is so much to write. I know it's so much to write. The oxygen atom, that's O, has 8 protons, has a much stronger attraction for the electrons, because remember, protons are positive, electrons are negative, so they are attracted to one another. And because it has a larger attraction to the electrons, it is referred to as electronegativity. So the oxygen atom is more electronegative than the hydrogen atom, because the hydrogen atom only has 1 proton. So what that means is that the electrons are, they spend more time orbiting. Remember, electrons are orbiting in those energy shells, orbiting around the oxygen atom than they do the hydrogen atom, which gives the oxygen a partially negative charge, and the hydrogens, both of them, remember the mouse ears, a partially positive charge, because if the electrons are focused on the oxygen more negative, that means they're focused on the hydrogens less, which gives them a partially positive charge. That is what makes the water molecule polar. And there are so many great things that we get because water's polar. Like, when you eat a pasta dish, right? And, you're lazy and you don't go, wipe off all the stuff right away. Carbohydrates especially form like a hard crust because water's polar. Oh my gosh, that's the district calling me, not calling me, calling everybody. Matter of fact, you're probably getting a phone. Never mind. You're not watching the video at the exact same time I'm recording it. Where was I? Oh, you can soak your plate in water for like 10 minutes. And stuff comes right off. That's because of water's polarity. It makes it a lot easier to clean things. That's why water is what we use to clean things. Water and soap, of course. Okay, I'm about to jump ahead to the next slide in 3, 2, and 1. Okay, vocab. Mixture, material composed of 2 or more elements. or compounds that are physically mixed but not chemically combined. So a mixture would be like you can still see distinctly the two different things. Perfect example, ice cream with sprinkles. Now, granted, the sprinkles eventually might dissolve if you mix and you add a little bit of heat to that. But when you sprinkle them on there, you can see two distinctly different things. Okay, that is a mixture. A solution, on the other hand, is when you add something and you cannot see distinctly different products. For example, when you mix milk in your coffee and you stir it up, you can't see where the milk molecules are and coffee molecules. They all look the same. There are plenty examples of mixtures and solutions. These are just the two best ones I had because you're probably familiar with what milk in coffee looks like and what sprinkles on ice cream looks like as well. All right. Again, for those of you that are typing, you're probably keeping up just fine. For those of you that are writing these by hand, which is how I always prefer to take notes because I learn more, because it takes a little bit longer. I have to think about it a little bit more. Typing, I'm a fast typer, and I just blast through the stuff. Yes, I'm a Duck fan. Yes, I know that I have a voicemail. You're probably telling me something that's going out to all parents because I am a parent of a student who is a junior at Rio, my son Gage. All right, here we go. I'm about to jump ahead in 3, 2, 1. Okay, still on number 15. I just kind of spread it out a little bit. So this is not number 16. This is number 15 for those of you that aren't listening. Not 16. 15. Okay. A solute. So in a salt water solution, table salt is the substance that is dissolved. Okay, so whatever solid you are putting into a liquid is the solute, and the solute leads to a solution. Okay, so even though milk is a liquid, when you're adding milk into your coffee and mixing it together, technically milk is the solute. Sugar is a better example. When you add sugar to your coffee, personally, I drink coffee black. I like the flavor. I don't need the sugar and I don't need the milk. When you add sugar and sugar dissolves in the coffee, sugar would be the solute. And of course, you can't see the sugar molecules after they dissolve. So we're talking solution, not a mixture. Solvent, water is the solvent. So whatever is doing the dissolving, and because water is polar, again, it can do a lot of dissolving. Oh, back crack. Ooh. Whoops. Suspension. We're not talking about, yeah, you did something really stupid at school, so you're going home for 5 days. We're not talking about that type of suspension. But it kind of makes sense. Suspension basically means it's kind of being held in limbo. Let's see, what are we here? Yeah, so like, for example, there are certain substances that if you add so much of them, even into warm water, they won't all dissolve. Salt, sugar. If you add too much, it becomes a super saturated solution. You'll still see the crystals sitting on the bottom. If they're light enough, they actually are floating kind of in suspension. Okay. So it just kind of means in limbo, going nowhere. And of course, if you're suspended and you're not doing your work because you're not contacting your teachers or your teachers aren't giving it to you, you're making no progress. You're just kind of sitting there in limbo. Okay. All right. So as you know, and we have mentioned many times, 2-1 and 2-2 are really, really heavy on the vocabulary. So if you're doing this for your class notes, rock on. If you're doing it for your reading notes also, fine. Because most kids need to write down definitions 2, 3, 4, 5 times before they actually remember what they are. And remember, you get to use these notes on your tests. So, well, You get to use these notes on your test if we're talking 2020 and 2021. And we might be back in the classroom next semester. You won't get to use your notes on the test. But for distance learning, yes, you get to use your notes on the test. So why not have it in multiple places? Okay, I'm getting ready to bump ahead. 2 and 1. Okay, whiteboard question. All right. I do want you guys to pause the video or let the video play out and go back and look these answers up. Every minute you spend practicing with your notes while you're doing them is a minute you're not going to have to spend studying for the test. Okay, because oxygen is more electronegative than, let me correct that right now. Gosh darn it. Sorry. Are you going to, oh, there we go. Okay, let me save it. And let's go back to presentation mode. Okay. Because oxygen is more electronegative than hydrogen, the blank spend more time near the oxygen and less time near the hydrogens. If you can't remember what that is, go back and take a look at number 14. I'll give you a clue. It's either protons or electrons. All right, for the first blank, and then more or less for the second blank. Okay, first answer. The electrons spend more time near the oxygen. That's why oxygen is more electronegative. And less time around the hydrogens. And that's why the hydrogen atoms are partially positive. Okay. A little matching for you. This is going back to number 15, vocab. Okay, mixture. All right, mixture is C, 2 or more elements or compounds. Solution. I think I know what that one is. Yeah. Solution is E, components are evenly distributed. Solute. Can't be A, because that's talking about substance where a solute dissolves. It's D, materials that do dissolve in water. Salt would be a solute. Sugar would be a solute, assuming you're not adding too much. Solvent is kind of the opposite of a solute. You guessed it. A, substance where the solute does dissolve. So that'd be water. Okay. Or coffee, if we're talking about adding sugar into hot coffee. And by process of elimination, that means suspension is materials don't dissolve in water. They just kind of hang out there. If they're light enough, they'll hang out up in solution. If not, they'll sink to the bottom. All right. Getting ready to bump ahead in 3, 2, and 1. Okay, acids, bases, and pH. By the way, when I say base or basic, alkaline, A-L-K-A-L-I-N-E, basic and alkaline mean the same thing. Okay, they're just different words that mean the same thing. Okay, water molecules either react to form H, hydrogen, pardon me, or hydroxide, which is OH ions. Hydrogen ions are positive, hydroxide ions are negative. And guess what? If you take a hydrogen ion and a hydroxide ion, H plus OH gives you H2O. Rock on. Okay, water is neutral because the number of positive hydrogen ions produced is equal to the number of negative hydroxide ions. Like I said, H plus OH goes to water. And of course, that's a chemical reaction. And we're going to talk more about chemical reactions in section 2-4 when we start talking about enzymes. Okay, the pH scale. Uh-oh. My goodness, Paulus. Sorry, I'm a perfectionist, especially when kids are watching my PowerPoints. Plus, when I actually do these in class, now they'll be correct. All right. Okay, pH scale, a measurement system for the concentration of hydrogen ions in solution, and it ranges from 0 to 14. Technically, it ranges from 0.0000001 to 13.9999999. Okay, there really is no zero pH. Okay, the lower the pH, the more acidic something is, and a lot of people associate the word acidic or acids with burning. You should also associate the words alkaline or basic with burning, because the closer you are to 0 or the closer you are to 14, they both will do damage. I mean, we're talking damage. Oven cleaner. If you've ever got oven cleaner on your hand or on your arm, OMG, scream and burn. Okay? Oven cleaner is alkaline. It's basic. Okay? So the closer you are to 0, closer you are to 14, they both burn. And it's basically reactions with the molecules in your skin that are happening, and those reactions release heat energy, and that's what the burning sensation is. Okay, I'm about to jump ahead to the next slide in 3, 2, 1. Okay, pH of 7 is neutral. That means the hydrogen ions and hydroxide ions is equal. Okay. Pure water is 7. Rainwater actually is slightly acidic. Rainwater is like between 5.5 and 6. Not enough to burn you. Oh dear. Sorry. Here come the yawns. Let's see. What do we got? Tomato juice. I don't drink orange juice in the morning. I've got kind of a sensitive stomach to acid. And I know that black coffee, I mean, really bitter black coffee is slightly acidic too, but I don't drink tomato juice or orange juice in the morning because it makes my stomach upset because it's so acidic. Milk, believe it or not, slightly acidic. Almost all citrus are going to be acidic. Apple juice is slightly acidic. Black coffee is 5. Okay, so it's not really acidic, but it's nowhere close to lemon juice. Gastric acid that you can see down there by 1. Gastric acid is acid that is released into your stomach to help break down food. Your stomach environment is super acidic, and that's that environment allows for more digestion to take place. And of course, we'll talk about digestion next semester. Sorry, my phone's quacking. I'm a duck fan. Okay, eggs, slightly basic. Baking soda, even more so. Hand soap, even more so. Bleach, it's got a lot of chlorine in it. Bleach will burn you. Okay, it's not like I'm just saying you put your finger in a cup of bleach and your finger's going to start dissolving, but you'll feel some reactions taking place, and you'll feel some heat. Ammonia, cleaning solutions, concentrated solutions of yeah, okay, fine. pH below 7 is acidic. More hydrogen ions than hydroxide ions. The lower the pH, the greater the acidity. pH above 7, those are called basic or alkaline. That means more hydroxide ions than hydrogen ions. And of course, the higher the pH, the more basic or alkaline the solution. And like I said before, closer to 14, the closer to 0 you get, the more damage will get done. Not too much more to talk about, you guys. Thanks for hanging in there with me. By the way, for those of you that are typing, you're probably just waiting. Number 23. It's like, who's number 23? I've never heard of number 23. Well, I bought the number 23 jersey because it was orange. The first year that they came out with the orange jerseys. All the new ones were super expensive. So I bought a used one of a kind of a less known player. His name was Ronnie Brown. And the Dolphins were running what's called the Wildcat offense, where they actually took a running back and had him accept the snap from the center. And you could run or you could pass. So Ronnie Brown could pass a little bit. That offense didn't last a whole long time with the Dolphins because they weren't very successful with that. But that's Ronnie Brown, and I got this jersey for I think like $15, and still wear it when I'm feeling orange. And of course, I've got my old school Reebok Dolphins hat on, and it's got a lot of orange on it. So I think I'm going to change into my Merino jersey for the game, though, just so you know. Okay, I'm getting ready to bump ahead in 3, 2, and 1. Okay, whiteboard questions. I would like you to go try to look these up. Water molecules react to form either blank or blank ions. What are the names of those ions? And if you're not sure, you might want to take a look back at number 16. We'll find the answer, 16. Not only should you know the names of those ions, but you should also know the chemical formulas and charges of those ions. Okay, so we're talking hydrogen ions, which are H plus ions, or hydroxide ions, which are OH minus ions. Good. What is the scale of measurement of acidity or alkalinity? What's the name of that scale? I hope you don't forget. You guys are like, what the heck is he talking about? That's bullet number 3 on number 16. And the reason why I said forget is the sound th is pH. It's also F, but pH. It's the pH scale. I have no idea where they came up with that and why it's a lowercase p and a capital H. I don't know. But that's the name of the scale. Lowercase p, uppercase H. All right. Acids have more blank ions than blank, while bases have more blank ions than blank. So the way that you do these here and on your test is, does this one go in the first blank and this one go in the second blank? Or does this one go in the second blank and this one go in the first? Acids have more hydrogen ions than hydroxide ions, while bases have more hydroxide ions than hydrogen ions. Okay. All right. Sorry I made that more confusing than it needed to be. But here we go. Getting ready to bump ahead to the next one. Remember, you guys do not need to write this stuff down. I do take test questions out of these and at the questions that are at the end. So if you want to write them down, great. Just don't number them because that's going to throw your sequence off. All right, number 20. Strong acids and bases. Strong acids have pH values that are 1 to 3. They will burn you. They will do damage. Battery acid is a strong acid. Oh, man. Back, my wife and I used to do the Renaissance Fair. Some of you guys might have gone to the Renaissance Fair. It's like the Renaissance period. People dress up and stuff. Anyway, rather than camping we used to get to camp because we worked there. We were camping in my minivan. I had a Toyota minivan, one of the first minivans ever made, actually. And my battery went dead. So I was the batteries in these cars are like inside the car, like not like in the front under the hood. I was leaning over it and I accidentally touched the negative to the positive and the positive and the negative, and it blew up. And thank goodness it didn't hit my face, but it hit my costume shirt and it had these holes all over the place. I didn't actually get burned, but battery acid will definitely burn you. So if you're ever jumping a car, okay, which is what I was doing, make sure the red one goes on the positive and the black one goes on the negative, or the black one goes to a ground, because otherwise you're going to be in a heap of trouble. Strong bases such as lye have a pH value from 11 to 14. Oven cleaner is a strong base as well. And the reason why oven cleaner is a strong base is because it's going to break down that stuff, that material that's stuck in the oven. It literally kind of like burns it, incinerates it, dissolves it. And that's what it will do to your skin if you leave it on your skin for a long period of time. Okay, buffers, and you'll learn about strong acids and bases and pH and all that stuff in chemistry. You'll learn about buffers in chemistry. The human body has lots of buffers in it. Buffers, their job is to, see how it's just barely above the picture. I knew that was going to work out. Buffers prevent dramatic changes in pH. So we have a lot of buffers in our body. So like when there's an acid in a location, it doesn't allow it to change the environment a whole lot. So one of the ways the body's control pH is through dissolved compounds called buffers. So they're what? No. My bad. Oh my goodness. I thought I was so smart. I guess not. Let's see how that works. Ta-da! Okay, so buffers are weak acids or bases that can react with strong acids or bases to prevent sharp, sudden changes in pH. You'll learn this when we start talking about enzymes and reactions in section 2-4. But reactions and enzymes are dramatically affected, and I'm talking in a bad way, by changes in pH, pH and temperature. So obviously, if these are important reactions that we need to happen inside of our body, we don't want the pH to change a whole lot because that's going to prevent the reaction from taking place, or it could potentially damage the reactants, like the enzymes. So these buffers are in our body to help kind of keep things stable. Okay. I'm so glad I've had this opportunity to make subtle changes to my PowerPoint before I'm doing it in class. Okay, that's a lot of writing. So if you're doing it by hand, you're probably going to need to pause the video. If you're typing, you're probably waiting for me. I'm getting ready to bump ahead in 3, 2, 1. Okay, little matching. Acid base, strong acid, strong base. So an acid in general, and if you're not sure, go back to that slide, number 17, number 18, and number 19. For strong acid and strong base, you're going to need to look at number 20. All right, so acid. Those are going to be pH values below 7. So that's going to be 0.1 to 6.9. Technically, it's going to be I'm done saying oh. Oh, sorry, duck fan. That's going to be a pH of 0.1 to 6.9. Okay. Again, it's pretty much anything above 0 to the smallest number above 0 to anything below 7, which is the largest 6.99999. Okay. Base, on the other hand, we're talking about anything from technically 7.01 to 13.99. So that's going to be D, 7.1 to 14. Strong acids are going to be the low end of the 0.1 to 6.9. So we're talking 0.1 to 3. And strong bases are going to be from 11 to 14. And of course, if you get a strong acid or a strong base on your skin, oh, good luck to you. Good luck to you. Wash that off with water. Matter of fact, I mean, the best way to counteract an acid is to throw a base on it because it becomes neutral. But I'm not going to get into medical advice with you here. Okay. Oh, really? How annoying is that? Okay. Blanks keep pH relatively stable, preventing large changes in pH. Are we talking about alkalines or are we talking about buffers? What keeps pH stable? If you're not sure, take a look at number 21. 21! Of course, that's buffers. Okay. You do not have to write down these questions, although some students do, because you're going to get a test question or two, that come from these, not necessarily this PowerPoint, but a molecule in which the charges are unevenly distributed. I'll give you a clue. Oxygen has a slightly negative charge. Hydrogens have a slightly positive charge. Water molecule, what do we call that? We call that a polar molecule. And the way that you would say it is you would say that the oxygen atom has a slightly negative polarity, and the hydrogen atoms have a slightly positive polarity. A dissolved substance is called a dissolved substance. What is salt when we put it in hot water? What's sugar when we put it in hot water or hot coffee? That is the solute. The two Utes. Sorry. That's a movie back from my day that you probably have no idea. A compound that produces hydroxide ions in solution. Hydroxide ions. That's a base or an alkaline. On a pH... hold on. Oh my goodness, I just gave you guys the answer. Sorry. I know. Total buzzkill. On a pH scale, a value of 2 means that the solution has equal concentrations of hydrogen and hydroxide ions, same concentration of hydrogen as pure water, higher concentration of hydrogen than in pure water, lower concentration of hydrogen. Remember, acids have a higher concentration of hydrogen ions than hydroxide ions, and of course a value of 2 means it's going to be a lot more hydrogen ions than pure water. Sorry, I ruined the surprise. Ladies and gentlemen, that is it for these notes. Remember, they need to be numbered. Remember, they need to be in Cornell note style. Remember, go Dolphins. Hoping to get our first win tonight. Patriots were a pretty strong team. Who did we play last week? Oh, yeah, my wife's team, the Bills. Man, that Josh Allen, that dude's a phenomenal quarterback. But Jags, I don't know. I don't know how good they are. Give me a go Dolphins, will you? All right, you guys, we will see you later. See you in the classroom. And this is Paulus signing off.